So when we go through this initial equation here, okay, you're really just looking for an initial value and a growth rate. Okay, so like as long as you can separate these pieces, it doesn't matter if you've got like just one of these simple ones or if you've got one of these crazy compounded ones. Okay, it looks like a little bit different formula, but it's really the same thing. It's an initial amount times a growth rate times whatever time you're putting in. How many times that growth rate's going to hit your initial amount. Okay, so now if we can find the same page here, this is going to be awesome. Okay, so let's just try one. All right, so I've got some baseball cards here that cost you 150 bucks in 1988. In 1994, the value of the collection had increased by 7.5% each year. Okay, what's the value of the cards in 1994? All right, here, let's maybe zoom in here a little bit. There you go. Okay, so somebody tell me, what's my initial amount there? 150, sounds right. So I can list this at 150. Okay, and that kind of makes 1988 my zero time, right? Like that's when I'm starting. That's when the growth is going to start on this 150, right? So I know that my rate, okay, is going to be, or my growth rate is going to be 1. Now, how do I do this? Plus, do I put 7.5 in? Yeah, you got to make it a number, 0.075. All right, and that's going to be where my B is, okay? So the percentage, why did I put the 1 in here?
Because it's not 7.5, it's 1.075.
Because you have to.
The 1 represents the starting point, right? That's the 150. So when I go and make my equation here, A of t is going to equal whatever my initial amount was, 150 bucks. Okay? And when I go and multiply that by my growth rate, I want to at least start with that 150. Right? That's what the 1 does. Guys, the back. Hey. Can I do this without you talking? Okay? Plus. Okay? And then this is how much it's actually growing on top of that 100%, right? So this is saying after, like my growth rate is going to be this 100% of what I started with, plus that growth rate that's going to hit it. Does that make sense? Okay? And then the T goes up here. All right? So this will give me all of the amount. So I can find after 5 years, after 10 years, after 20 years. Let's just see what the graph looks like in the calculator here. This is a really specific question. Like if I go in to answer this question now, I just have one value that goes in. But I think better if we just take a look at the calculator here quick. See if we can get this both on there at the same time. And let's make a new graph. Okay, so I'm going to get 150 times 1, I guess I should put that in parentheses, 1 plus 0.075 all to the exponent of, and you need to put the x, right? Okay, so when I push enter, what do you think I'm going to see? Nothing. Okay, because I'm starting at 150 and all I've got is 6 here, right? Okay, so the table is going to give us a little bit, like we know we're starting at 150, but this is going to give us a sense of what kind of numbers we're going to get out. Okay, so after 10 years, check it out. We were talking about that doubling time, right? Being about 10%, or at 7%, we would take about 10 years. Okay, it's a little bit more than double at 10 years because we're 7.5. All right. So I can kind of see how I want to set my graph up now. My biggest number, I want to start at what looked like it was going to be about 300 after 10 years. So I go into my menu, go to Window, and it doesn't matter here. Like, we can make the graph go as far as we want. I'll go up to 15. I don't have any negative values, but I'll leave a little space over there. Whoops. I'll leave a little space over there to so we can have some room. Okay. If this is going to be 150 to start with, after 10 we said it was around 300. I'm just going to set it at 400. So we go a little bit beyond that. And here, if I've got 400 here, kind of half of that might be nice to have at the bottom, so we can see what's going on. And there's your graph. Okay, so you can do all sorts of things here. So the question they were asking is, in 1994, how many more years is that after 1988? 6. So that's going to be, and this is kind of important. Like, when you go to do a quiz, you kind of need this general equation to start. That's one point. Then this part that tells me you know what's going on, A of 6 is the second place, the second point. Okay, so now I'm going to go menu. Trace is probably the best thing to use there. And I'm just going to put 6 in. And that gets me 231. 50, I guess. Okay, so we've always kind of harped on 3 decimal places, but we're talking about money here, so you just do dollars and cents. Okay, so there's that. What other kinds of questions could I ask here? I could ask, when are those baseball cards going to equal, let's say, $300? And you would set it up like this. Right? And so how am I going to do that on the calculator? Yeah, so I want to put another graph in that gives me 300. And then I'm just looking for this point, so you do an intersection. Okay, all the same stuff on the calculator as we did before. I just kind of feel that the window is where people kind of get messed up. So it looks like it's going to be 9.584 years, I guess. Okay, so that's a growth. Right, let's do one more here. Let's look at number 2. Is that okay? Nothing serious there, right? Like, it's the same calculator skills that we've always done. It's just the setup. And the biggest mistake people make, the 2 biggest mistakes, I guess, is they won't add the 1. And here they put 7.5 instead of 0.075. They don't change the percent to a number. It really is the only 2 places where there's any trouble here. Okay. This is called, this is doing depreciation. So here we're having decay instead. So I buy a new car, $16,500. They're not in Singapore if the new car costs $16,500. But anyway, Torgerson just scrapped his car. He got $500 for it. It's 20 years old. Anyway, 16,500 is where we're starting. Okay. So my equation is now going to become,
1 minus.
yeah. Okay, so A of t, when I put the time in, I'm going to be 16,500 times, and then 1 minus 0.12, all to the t. Okay, so same, and then it's the same exact deal. But just make sure that you don't, like a lot of people here, the big mistake is they'll put 0.12 in here and think that that's depreciating 88%, right? Here, the actual number that we want to dump into the calculator is 0.88. I'm going to have 88% of this number after each year, right? Okay, so you put your 3 on top, you do the same calculator skills, and you're set. All right, let's stop that there.